are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Tree Level. So now in this video, we are going to start with the very first idea and talk about indexing. Okay, so let's quickly get started. So indexing is basically a data structure technique, okay, which allows you to quickly retrieve the records from a database file. Right now, think about it this way, what I was talking about in the introduction as well. You have such a large data set, right? And you have to search something, you have to fetch some records, you have to retrieve some records from that database. Now, if you will keep on applying the typical approach of, looking through all the records one by one and then, fetching the required result, it is definitely going to be an extremely slow process. Okay, so what we do is we need something faster to do over here, and indexing is that technique that actually allows you to quickly retrieve records from a database file. Okay, now basically an index is a small table, okay, having only two columns. So what we do in the concept of indexing is we make an index table. Okay, now in the index table you basically only have two columns. Okay, the first column consists of the primary or the key candidate of the table, right? So what you do is you have two columns in the index table. The first column will always either be the primary key or the candidate key of the table. Okay, and the second column is basically going to be a set of pointers, okay, which are basically holding the address of the disk block or the disk position where that specific corresponding key is basically stored. Okay, so it's something like this. When we talk about the concept of indexing, okay, remember you have a very large data set. Which is having a lot of data. Okay, here is, let's say, the key and like a lot of columns, and let's say key 2, key 3, key 4 and so on. And now you need to be able to access this data very fast. So what do? Is you make an index table. In the index table, the first is the key only and the second are pointers. Okay, so what do? Is let's say for 3 is one of the value, and in here you are basically storing a pointer which is pointing towards the address where the key 3 is stored. Okay, then let's say you have 4, then here you are storing a pointer which is basically storing the address, right? Pointer is pointing towards the address where the particular key 4 is stored. Okay, and that is what it says over here as well. The first column comprises of a copy of the primary key or the candidate key of the table. Okay, and the second column contains a set of pointers for actually holding the address where the key value is stored. Okay, now here the index basically searches a key as the input and efficiently returns a collection of matching records. So what will happen is whenever, let's say, you have to fetch some records, right, you will basically have, what is the process now for fetching records? Okay, you will basically get a key in the input, right? You will look in the index table. Let's say the key that you're looking for is 4. You will look in the index table, you directly know where it is stored, so you will go to that particular position and fetch the records. Okay, so that is how this basically works. I'll repeat it once again over here, that you basically will have to here present a key, right, for which you are looking for and which you are searching for. You look for it in the index table, you will find that key, you will find the address also where the corresponding record is stored, and you will fetch the entire record. Okay, and that is what it says over here. An index basically takes a search key as an input and efficiently returns a collection of matching records. Okay, so that is what the basic definition is. Indexing will allow you to quickly retrieve the records from a database, right? And it is basically consisting of an index table. The first column is the key and the second column is the pointer, which is holding the address. Now next we can talk about what are the different types of indexing which is present in DBMS. Okay, the first kind of indexing is the primary indexing. The second type of indexing technique is the clustering indexing, and the third type is the secondary indexing. Okay, and the primary indexing is further divided into two parts. There is the dense indexing and then there is the sparse indexing. Right now, this is what basically forms the entire structure for talking about indexing as a concept. Okay, again, three types of indexing: primary, clustering, secondary, and primary is further divided into two parts, which is dense and sparse. Okay, so what we'll do is we'll start with the very types of indexing first and then cover all of them. Okay, indexing in the database, it says, is defined based on the indexing attributes. Okay, what are the attributes which are basically indexed are known as indexing attributes. And two main methods, right, which are actually used for indexing is primary and secondary, as you can see over here. Clustering is also used, but the main two types are primary and secondary. Okay, so now what we'll do is first talk about primary indexing in DBMS. So what happens in primary indexing is that primary index is an ordered file, okay, which is of fixed length size which is having two fields. The first field is same as the primary key. Okay, whatever in the table you have the primary key, in the indexing table also the first column or the first field is always the primary key, and the second is basically filed to basically point towards a specific data block. Okay, in the primary index there will always be one-to-one relationship between entities in the index table. Okay, so what happens is, let's say here we are talking about primary index over here. Okay, so what happens in that, let's say you have a table and in that you have the ID, okay, which is the primary ID over here, and there are some more columns as well. So whatever index table you create, okay, in primary index, remember it's primary over here, right? So whatever is the primary key over here, let's say in the original table ID is the primary key, so here the first column also will be the primary key itself. Okay, and here in the second column, which is basically a pointer pointing towards a specific block. Okay, and that is what it says over here, that the second column or the second field is pointing towards a specific data block. Okay, and here in primary index you always have a one-to-one relationship. All right, always remember that the one-to-one relationship exists in primary indexing. Now the primary indexing is basically further classified into two types, like we just discussed, that it is for dense and it is for sparse. Okay, just to reiterate on the definition, always remember that if the index is created on the primary key of the table, then it is known as primary indexing. Let me write it down as well so that you can remember in this sense that when we talk about primary indexing, okay, if the index is created, this is like a simpler definition of what we have written in the slides, is created on the basis of primary key of the table, right, then we can say then it is known as primary indexing. Okay, those primary keys are unique obviously to each and every record, and they contains primary keys always maintain one-to-one relationship with the records. Correct, that is what we already know. Okay, always remember, as always it will happen in a table, that as primary keys are stored in a sorted order, okay, always and always in a table primary keys are stored in a sorted order, then because of that the performance of the searching operation in primary indexing is optimized, is quite efficient. Okay, and the last point being that the classification is further on 2 points. We have sparse index, okay, and then we have dense index as well. Okay, so we can take a look over here. First, let's talk about dense index. So what happens in dense index, a record is created for every search key valued in the database. Okay, this helps you to search faster, but it actually takes more space also to store the index records. All right, and in this indexing, right, method records actually contain search key value and they point towards the real record in the desk. Okay, so what is dense indexing? In dense, like, try to remember these concepts with the very name itself. Okay, dense and sparse. So dense, when we talk about, it means that a record in the index table is actually created for every search key valued in the database. Okay, so if you have 10 keys, right, or 10 records in the database, you will have 10 records in the index table as well. So how does that help? It actually helps you to search a little bit faster. Okay, helps you to search a little bit faster, but the problem is that it takes more index records as well. Here you can see in the diagram itself, right, that if there are records for 10, 20, 30, 40, 50, 60, 70, 80, and all these 10 to 80 numbers are primary keys, okay, then all of these are actually stored in the index table as well. Okay, all of these records, none of the records are actually missed. So this helps you to search faster, but the problem is that it takes more space, right, because you have to actually make a record for each and every row in the index table. Okay, so what happens in this kind of indexing is that this method actually contains the search key value, and actually, so here the first column is definitely the primary key, but the second column is the pointer which is actually pointing towards the real record, right, in your disk, in your memory, wherever actually that record or that row is stored in the database. This pointer for, let's say, 10 is actually pointing towards that record itself. Okay, so it's not pointing towards any other value but directly pointing to the record. That is why we said that here the searching operation is comparatively faster. Okay, let's kind of concretize these points as well for dense index. Okay, so whenever we talk about dense index over here, always remember that the dense index contains an index record, okay, for every search key value in the database. Okay, that is what we talked as well, that there will be an index for each and every record. Okay, so hence it makes the searching faster. Okay, in this, the number of records, always remember that since we are storing everything in the index table, hence we can say that the number of records in the index table is actually equal to the number of records in the main table, right, because we are storing for each and every thing. Okay, hence because we are doing that, it needs more space, okay, to store the index record itself. Now, although it will make your search operation faster, but do you realize what the problem is? That to actually store the index table, it will take up a lot of space. Okay, and here we have a pointer in dense index for every record in the index table, which is actually pointing towards the real record. Okay, so let's say if I take an example over here for like the country and the corresponding one state in that. For example, we're talking about UP, and inside that we're talking Agra, okay, which has, let's say, population of 1 CR. I'm just taking a hypothetical example. Let's say then we are talking about USA. For every country we are taking a space, one state. So we have Chicago, okay, and let's say it has the population of 2 CR. Let's say we have UK and we have Cambridge and it has the population of 30 lakhs. So in this case, let's say if this is the table and if this is the primary key, okay, so what will the index table basically look like is that in the index table you will also have UP, USA, UK, okay, 2 columns. First column is the primary key only and the second column is actually pointing towards the real record. So that is what dense indexing is, okay, and you can see a very valid example on the screen for this as well, okay. The second that we talk about is the sparse index, okay. So what happens in sparse index is that it is an index record that only appears for some values in the file. So you actually are not storing all the records in the main table and you're not storing the index for all of that in the index table, okay. As it says, it only stores only for some of the values, okay. So sparse index actually helps to resolve the issues of dense indexing, right? So when we talk about dense indexing was faster. But what was the problem? What was the issue with dense indexing? The problem with dense indexing was that it was taking up a lot of space. So sparse indexing actually solves that problem of dense indexing, okay. So in this method or in this technique of indexing, right, what we take is we actually take a range of index columns, okay, only, and store the same data block address, okay, for all of them. And when the data needs to be retrieved, that particular block address, so instead of storing the address for each and every row, we actually take a range of records and we store the address for all that combined block, okay. But remember, however, sparse index stores the index records for only some search key values. Since it is sparse, it's not going to store for everything. It's just going to store for some of the key values. So that is why it takes less space, it takes less maintenance, it has less overhead of insertion also. So remember, in dense indexing, every time you add a new record, every time that new record needs to be updated in the index table as well. But in sparse table or in sparse indexes, in fact, there is a little bit less overhead for that, okay. And so there is less overhead for insertion as well as for deletion. But the disadvantage is that it is comparatively slower compared to dense indexing, okay. So here you can take an example. So now instead of storing for the address for all of it, okay, what do you do is you just store it for some of them. So in sparse what you do is you have a very big data set. Let's say these are the primary keys. Okay, now instead of storing the index table values for all of them, I will just do, let's say, 1, and I will do this, and let's say I will do 4 and I will do this, then I will do 6 maybe, and I will do this, and I might do 9 then, and I point to this, okay. So here, instead of storing the indexes for all the records, I am just storing for some of them. So let's say if someone wants to search for 2, right, I will see for 1, and then corresponding to that I will have to do 2. Whereas if 2 would have directly been present, it would have been faster, but that was dense indexing. In sparse indexing, like I said, it takes less space, but it takes more time to actually search for a record because you're not storing indexes for each and every record, okay. So just to summarize what happens in sparse index, okay, is that in sparse index records, right, whatever index are in the index table, it only appears for a few records and not for all the records. Okay, each item in index table does not point to a single record. It actually points to a block of records. Correct? Why? Because here if you can see that now this one is not just used to access one, but it is actually acting as a block of address for all these three records. Okay, so that is what it basically works on. All right. So in this, what happens is instead of pointing to a record in the main table, we actually point to a group of records in the main table. Okay, so I hope this concept is clear for dense and sparse indexing as well. Okay, so pretty much the concept is very simple, right, and very, I would say, verbose and simplistic to understand as well. When we try to compare dense and when we try to compare sparse indexing, what we see is dense is faster, okay, because it is literally one record, one index record. Sparse is a little bit slower because we are storing address for a group of records. Dense takes more space, right, because we are storing for each and everything. Since we are not storing for each and everything, sparse takes less space. Okay, so now one can come up with the question that, ma'am, when should we prefer which? Okay, so the answer for that is actually very simple, that if you have very large data set, right, that can then you can go with sparse indexing. Why? Because it will take less space and the performance would not be that much compromised. But if you have a small data set, then you can actually go for dense indexing as well, when the data set is not very huge, right, so that it doesn't take up a lot of space also, and it's faster for you to do operations as well. But again, to say that this answer is generalized, it would be wrong. Sometimes it depends on your use case, sometimes it depends on the type of data that you have, right, sometimes it depends what kind of primary keys you're having, sometimes it's a cluster of primary keys, so it's like a lot of factors which gets included. But yes, pretty much this is what the concept is for dense and sparse indexing. Okay, so I hope this is clear to everyone and you actually get a realistic view about indexing as a concept as well. And not just that, in that we have actually covered the first leg also, which is primary indexing. Okay, so primary indexing, wherein always the first column will be the primary key and the second column will be a pointer pointing towards either the entire record or a group of records. Dense, one record; sparse, a group of records. Okay, so that's what the idea is. So I hope it is clear to everyone. What I would recommend is to actually take a few examples also and then try to do this, right, and make sure you understand the concept of indexing. Indexing might look like a miscellaneous concept, but it is actually very, very important. That is why we are taking examples again and again to fully comprehend and understand the idea. All right, so thank you so much for attending this video, and I will definitely see you in the next one, where we will talk about secondary and clustering indexing. Okay, thank you. Bye.